Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members into our discussion for today. So we are going to look at the potential energy and the concept of conservative forces. But in our case, we are also going to look at some of the elements of description for work in relation to potential energy and the effect of this specific aspect of conservative forces, or how we can basically try to identify this aspect of conservative forces. Now, in our previous discussion, we had looked at the concept of work energy theorem, which of course is going to be including the work done by all forces acting on an object. Now, suppose we consider this aspect of gravitational forces. We are going to have to distinguish this specific aspect of gravitational force with the concept of applied forces, which we had mentioned in our previous discussion on the concept of different types of forces. Now, suppose we have a ball which is being thrown upwards. We can give this specific, of course, illustration for that ball, just a rough illustration of this specific ball being thrown such. So as the ball goes up, it's going to be losing the kinetic energy, but it's going to be gaining in a potential energy. Now we can have different ways in which we are going to represent this specific analysis for the ball, which is going to be losing this specific aspect of course, kinetic energy while gaining the potential energy. Now this can be described by trying to look at this work done by the gravitational force that's going to be associated with the change in potential, whereby if we had this specific ball which was located at the ground level given in terms of h naught, and it has been displaced to a level of this specific point of h, we see that we can give this potential energy in terms of the product of mass times acceleration, and of course this particular aspect of height, which can be given in terms of the difference between h and h naught. So therefore the change in potential energy is going to be of course associated with this gravitational force. And of course we can just try to look at this one of course in terms of an analysis. And the forces which are going to be related to this potential energy are going to be regarded as of course conservative forces. Now, from our previous definition of the concept of conservative forces, we had looked at an example of a circular trip, whereby we see that if we consider an object that is moving in a circle, we're going to have this specific object described by the distance between of course the point of action and this specific object. And of course we said that we can describe the velocity component of this specific, of course, object in motion given in terms of these particular angles of interaction, and therefore there are going to be tangential components along this specific aspect of this particular track. So we are going to consider this particular case, and I mentioned that we can find the element of work of this specific nature by finding the force times the displacement given as a delta x, and of course we're going to have the cosine of this specific angle given in terms of the cosine of theta. So in case we consider this theta to be 90 degrees, we're going to see that the work done basically is going to be an element of a force delta x, and the cosine of this specific value, which is going to be the cosine of 90 degrees, is going to be giving us a 0. So in this case, therefore, for an object that's going to be moving in this particular case, is going to be having its net work done given in terms of 0. Therefore, we can consider this specific force as a conservative force if the work done by the force on the particle that moves on a round trip is going to be 0. And the alternative to this one, of course, if there's some work done for an object that's going to be moving around this specific track is not equivalent to 0, then therefore we're going to consider that one to be what we refer to as a non-conservative type of a force. So we're going to look extensively at these types of forces as we go by, but in this case we have just mentioned that basically we can have this specific representation for those conservative and non-conservative forces, which can be described especially using this specific example that I've given for the movement of an object around the track. So in case we have this element of a change in kinetic energy or the work. So from the work energy theorem, of course, we can describe this change in kinetic energy as the work done. And of course, if the work done, and of course, which can be represented as 0, of course, in a round trip is equivalent to 0. So this is going to be depicting the element of a conservative, so this is going to be given as so my handwriting is legible. This is going to be conservative kind of forces. And if the opposite is true, whereby we're going to have a delta K naught equivalent to 0, and of course W naught equivalent to 0, and therefore these are going to be non-conservative type of forces which we are going to come across. So as just given that a specific example of a ball on my right side of the board, which you can just use the same analogy in trying to find when the ball is going up and coming down, and try to see that basically we can regard this gravitational force of mg being given as that one, which is going to be doing some negative work. And of course, it's going to be, of course, coming down, the gravitational force is going to be equally doing a positive amount of work with regard to this specific description given as such. So in this case, we're going to consider this ball as it rises from ground to the highest point, whereby we have decided that we can give the displacement s in terms of the difference in height of h1 and or h and h naught given as that one. So the change in potential energy can be given for this case as of course, perhaps I can give this one change in potential energy given in terms of U minus U naught. So these are displacement, the change in potential energy given in terms of U minus U naught. And in this case, we have said that this is going to be a positive value which we are going to realize from this kind of motion for the ball. And this change in potential energy is going to be a negative value of the work done by gravity. So in this case, I said that the work which is going to be done by gravity, so the work done by gravity can be given in terms of the negative value of mg h minus h naught. But we have seen that this specific change in potential energy can be given in terms of the negative value of the work done. So which means it is going to be having a positive implication for the mg h minus h naught, and that is going to be giving us this specific relationship. So the work done by gravity is going to be a negative value of this specific work, and that's going to be basically explaining the two aspects which I've just given. So therefore we can give this element of a change in potential generally given in terms of mgh, and of course that is going to be giving us the work energy theorem. So we can as well evaluate the mechanical work which has been done in this particular case. And we see that basically for us to evaluate this aspect of mechanical energy involved, this is going to be a sum of the potential energy involved plus the kinetic energy which is going to be involved. And it's going to be forming our mechanical, of course, energy being involved in this case. Now, when there's no work done in this particular case, we're going to see that this specific aspect of energy is going to be constant or conserved. And of course, we're going to see that if the applied forces do work, we can, of course, give this specific aspect of energy over the kinetic energy plus this specific energy given in terms of, so if we are to have this specific kind of work conserved, we have this one. But in case there's some work done, we can of course include this aspect of some work done given as such. And therefore we're going to see that this can be given in terms of the energy is equivalent to the initial energy plus some work done given as W. So this is going to be W naught given as that one. So this is going to be giving us our description of the mechanical energy involved in description for various kinds of scenarios which we are going to come across,